Good morning. Today we discuss MANOVA case study as supplement to this week lecture on MANOVA. This case study will help you to understand the application of the concepts and theories and the statistical derivations what we have done so far in terms of MANOVA. The contents include first case description, then variables and measurement, sample and data collection, then what are the MANOVA results and interpretation of the results. Let us see the next. Today we will discuss a case study on MANOVA. I think you have not forgotten MANOVA, and I am just 5 minutes discussing that basic concept. Then we will straight away go to the case study because the details of MANOVA is already given to you. Now we have seen in ANOVA there is a little number of populations and number of and different observations I, and we have taken only one observation XIL, and then this observation is broken into X bar plus XL bar minus X bar plus your XIL minus XL bar in ANOVA. That is the case. And then we have ultimately in one way ANOVA we have ultimately found out that SST equal to SS, I can write SSA plus SSE. If I say this population we are denoting in terms of A, so it is A1 to A capital L. So this one for ANOVA, and in MANOVA we have just in one way MANOVA we have just duplicated the same thing, but with one addition. That addition is number of variables. I think you can remember this observations in populations, that capital L. So A1, A2, then AL to A capital L, then 1 to N, and it is X1 to XP. So when P is greater than equal to 2, that it is the issue is no longer ANOVA, it is a MANOVA issue, multivariate analysis of variance. So our notation was similar like ANOVA we have kept, but this quantity is a vector quantity, and we have described in the same manner like X bar plus XL bar minus X bar plus XIL minus XL bar, and this is again we have found out that the SSCP matrix total equal to SSCP, suppose the A factor or a population effect plus SSCP E. If there are P variables, this could be P cross Q, this will be P cross P, this will be P cross P. Okay. And also what we have learned so far in MANOVA, that we will test a hypothesis. That hypothesis was that mu 1 equal to mu 2 like this equal to our, we are saying mu L, and alternate hypothesis was mu L not equal to mu M for one pair of, for at least one pair, for at least one pair of LM, that, and then we created Wilks lambda. Wilks lambda is determinant of SSCP by determinant of SSCP total, and we created one another statistics, and that follows chi-square distribution, and then based on this we have seen that whether the statistics is showing that whether there is significant differences across the mean values of the different level of the population. Okay. Before that, what we have done? We have also done box M test for equality of covariance matrices. Covariance matrices. Okay. And that means sigma 1 equal to sigma 2 equal to sigma L equal to sigma. If this condition satisfied, then what happen, this weak lambda and other statistics values, those things will give us much accurate result compared to situation where these are not equal. If the covariance matrices are not equal, can we still use MANOVA? We can still use MANOVA. In that case, the suggestion is try to make equal sample size and use not only Wilks lambda, you go for some more statistics like Pillai stress, raise, largest characteristic root. So, there are many techniques available. We will see all those techniques, and if those all techniques suggest that there is difference, then only we will go for difference. But even then, please keep in mind that when there is violation of assumptions like multivariate normality, another one, and the second one is the first one. First one is normality, second one is this violation is there, and the populations are independent population. That is not a big issue because it is usually true, independent population. Then independence of observations, correct. So, these things you have already seen. So, with this background, I am presenting one case study and see the result. So, the content of the case study presentation is, first I will describe the case, then what are the variables we have considered and how we have measured the variables, what data we have collected, what results we got using MANOVA, and what are the interpretation of results, finally some references. Okay. This is a real case study we are doing now. So, the study is conducted in a coke plant of India. 3 groups of employees we have considered: officers, maintenance workers and operation workers. Purpose: are these 3 groups of employees differ in experiencing job stress? You all know job stress is nowadays it is a big issue everywhere, across all job titles, across all sectors, starting from your hardcore heavy industry to small scale industry to office workers to IT workers. Job stress is a big issue, and this work we are doing for one company. They want to design for, they want us to design something for job stress, that means to manage job stress, and that is also engineering design. But as you all know that engineering design starts with customer requirements. So, you must understand what is the requirement and then accordingly you design, and then the design will ultimately fulfill the requirements, that is the process. So, this study is coming under customer requirements or customer attributes, customers attributes identification or customer requirement analysis. This is our study. So, we have considered HSE job stress risk factors. What you require to do? You must have response variables. In MANOVA, you have seen that number of variables, this is one of the dimension here, number of variables. So, these variables we are saying these are response variables, plus I think yes, this is related to response variables only. Now, response variables can be 2 or more here in this case MANOVA. What are the response variable in our study? In our study, the person working is imposed or exposed to certain amount of demand because of its job, that like workload, work pattern and work environment. Then there are certain amount of controls, because you have the responsibility, you have the job, you have to execute the job, you must have control on your job. So, how much say one has in doing his or her work, that is the definition of control here. Then management support. So, encouragement, sponsorship and resources provided by the organization, line management, these are coming under management support. Everybody working in an organization requires all those things, otherwise he or she cannot work in this environment. That support is very, very important. Fourth one is peer support, means your colleagues must support your work, your feelings, they must help your day to day work, they must help you in for your well being also. If those things are absent, then job stress will become more. So, then relationship, promoting positive working to avoid conflict and dealing with unacceptable behavior, that is in the work, in the job. Then role, whether people understand their role within the organization and whether the organizations ensures they do not have conflicting roles. When you are given a job, for example, you are doing research work. So, it's a time bound definitely job, that 3 years, 4 years you will take to conduct. So, you must know what you are going to do, and your guide also at the same time, he also support that your views, your ways of doing. Guide is looking for some way and you are doing in some other way, then there will be conflict. So, similarly in the job, the organization wants the job to be done in certain way and you are doing in some other way. So, what will happen then? Conflict will be there. When there is conflict, there is stress. Getting me? So, we are saying that role should be crystal clear, there should not be any ambiguity in understanding the roles, what I have to do. If there is difficulty in understanding what I have to do, and ultimately even my performance will be very poor, and because of poor performance the stress will accumulate and one day burnout situation will come, and that is very, very typical issue now in all industrial sector. Even in academics also nowadays it is the situation is like this. Then finally, the other variable is real change. Many a times what happened, you just see, so this is a case study. So, we understand the totality, how we are going for the case study, not the MANOVA technicalities we will be discussed here. We will be discussing a case study with the application of MANOVA. Now, change is another. So, that is why I am explaining. So, please when you go for similar studies, either in your research or project or in consulting work or any in your professional work, please understand the purpose of the study, the variables must be clearly understood. So, you must know for the purpose what are the key variables. Here we are talking about response variable, there are HSE 7 risk factors. So, the 7th risk factor is change. Change means what? There is a change in job profile, in that sense that organization want the job to be done by suppose single working to group working or group working to some mechanization, semi mechanization, some changes is required because of improving productivity. Okay. So, these changes must be properly managed by the organization, otherwise what will happen, you will find out that people will not accept, worker will not accept it, and worker in the sense the employees will not accept it, and ultimately employee will be frustrated also because of this. And this change, if it is not well designed and well communicated, then there is a question of job stress. Getting me? So, that means in nutshell, in our case study, how many P's are there? P equal to 7. So, 7 response variables starting from demand, then control, demand control, then management support, then peer support, then your relationship, then your role, then change. So, these are the 7 risk factors which are, or other way I can say, employees are exposed to all those risk factors. These risk factors are developed by HSE, Health and Safety Executives UK, Health and Safety Executives UK. So, we want to first work is we have to measure those variables. How do we measure? HSE has given questions against each of the factors. Okay. For example, that in order to measure demand there are 8 questions given. So, for control there are 6 questions. So, questions are there, these questions will be administered to different group of people and their response will be collected, those responses will be the our measured values, correct. Now, you see this table here, demand control, management support, all those things, HSE questions, first case demand 8, control 6 questions, management support 5 questions, PR support 4 questions, relationship 4 questions, role 5 questions and change 3 questions. Totality there are 35 questions I think, 8 plus 6 plus 5 plus 4 plus 4 plus 5 plus 3. So, 5 plus 8 plus 8 16, 21, 21 plus 6 27 plus 8 35 questions. So, 35 questions are used to measure the job stress suffered by different people at the organization. Now, what are the sample question? For example, the question number 3, this is different groups at the employees are being asked this question. Different groups at work demand things from me that are hard to combine. This is one of the question related to demand imposed on the employee. Control, I can decide when to take a break, that means he has control. Management support, one of the question is, out of these 5 question, one is I am given supportive feedback on the work I do. PR support, if work gets difficult my colleagues will help me. Relationship, I am subjected to personal harassment in the form of unkind words or behavior. Role, I am clear what is expected of me at work. Change, I have sufficient opportunities to question managers about change at work. Getting me? So, there are such 35 questions. Each of the questions must be measured. What is the measurement scheme? Measurement scheme is Likert scale. In the Likert scale, when an employee is asked a question related to demand, control or any other factors, then for every questions he or she was given a scale 1 to 5. Whether the question, with respect to the question, the respondents strongly disagree the statement, disagree, neutral, agree, strongly agree. So, it is basically a ordinal data. In order for every questions you are giving, first one, that is the 1, it is strongly disagree. Then 2, your disagree. 3, this is neutral, not, that is neither neutral, neither agree, not disagree. 4th one is agree. 5th one is strongly agree. Okay. So, then how the data is collected? Data is collected in the same manner for every individual. If I say I is the nomenclature for individual. So, first one, he was asked the question 1, question 2 like this, question 35. And out of these 35 questions, 8 questions related to demand, 6 questions related to control, 5 questions related to your management support, 4 questions related to your peer support and so on. So, then everybody who were respondents there, suppose the first question he completely disagree, then the value will be 1. For the second question, suppose he completely agree, then the value will be 5. For the similarly, for the last question he may be completely neither agree not disagree, neutral. So, value will be like this. So, in this manner, suppose n number of persons were asked the 35 questions and they have given the values responses. Okay. So, this is what is the level of data collection, first level of information, that for everywhere you are collecting like this, that is from the measurement point of view. Okay. So, how do you collect the data? This is coming under study design now. What was our study design? See, application of statistics will be felt useful only when you do the real work. So, our study design was, when we have seen that this is the total organization, here organization with respect to our coke plant. So, this one is coke plant. Then what we have found out that there is officers level workers and shop floor workers. So, we are writing like this, officers and shop floor workers. Then in officers, shop floor workers, there are operations workers, or I first one write maintenance workers, this way we have designed. Then operations workers. So, this is our stratification. This is our stratification. Correct. Now, what sampling we have used here? It is basically stratified randomized sampling. What we have done? We have taken officers as my population 1, maintenance worker as population 2 and operation worker as population 3. Then what we have found out? We have seen that what is the number of people working in this category, number of people working in this category. So, N1, N2 and N3, these are the number of people working. Then there is one concept called sampling theory. In sampling theory, you will find out that if N1 people are working in this group, or in totality in organization, that is the N people are working, where N equal to N1 plus N2 plus N3 in this case. These people are working. Now, officers work, maintenance workers, operations workers, so many people are there. So, again there are 7 factors. So, you will be measuring for everywhere 7 factors. So, then how do you decide the sample size? What do you mean? What will be the N1 value, what will be N2 value and what will be N3 value? How do you decide? You have to use certain scientific methods. One of the method I told you, that frequency matching. Frequency matching means if there are 100 workers working here and you suppose you collect 30 and here 200, so it should be 60. Suppose here it is 50, then it will be how much? If 100 will 15. So, 15, this is what is known as number of people working vis-a-vis the sample collected. But there is one problem here. Problem is that there are 7 variables. If there is one variable, fine, that this may be frequency with 7 variable, some of the variables having high variability compared to others. So, it is that is why what is required, you have to find out what is the highest variability variable, I mean what is the variable having highest variability. You consider all, there may be simultaneously you consider everything, you go for a pilot study irrespective of maybe that stratification, or with stratification will be better one. Then with this pilot study you find out which one is having the highest variability, then there is formula, Newman algorithm and other algorithms are there. Using this formula you will be able to know what are the sample size required. Okay. So, doing such calculations we found out that in officers we require 54, maintenance worker 96 and operations worker 146, because number of operations workers are more than maintenance workers and officers much less. So, this is what I can say the sample size determination. And when we administered the questions to the officers, 54 officers were selected randomly. It is not that we have selected one by another, it is randomly selected. Similarly, 96 maintenance worker, 149 these workers, this is selected randomly. Okay. So, this is my data. For analysis purpose, we have done little modification. What is this modification? Modification is like this, that job stress is a negative sense variable. That means job stress higher means not good, but demand is also, if demand is higher, this is also not good. Then I can say they are in one quadrant, same quadrant. For example, if I say there are two quadrant for that positive positive and negative negative sense, or positive negative and negative negative, negative positive, that is not the, this is the quadrant conversion, it may help you later on. This is my positive positive quadrant, means if this is my one variable x 1, this one another variable x 2. So, x 1 increases, x 2 increases, that both positive. This one is x 1 is, write down x 1 this side, then x 1 negative positive, and this one is again negative negative, this is positive negative. So, what we wanted here, as job stress is a negative quantity. So, we want to convert each of the predictor that the risk factors, each of the risk factors in either positive positive or negative negative, that sense means same sense. So, demand, if demand increases, job stress increases. So, relationship will be like this maybe. Now, if control increases, if I write here control again, then job stress will decrease. So, that means this is one increasing, other decreasing, we do not want this. We, in order for comparable analysis, we have made everything one sided, either increasing or increasing or decreasing, actually it is increasing case. So, instead of demand we are writing excessive demand or excess of demand, lack of control. So, lack of control increases means job stress increases, then support, absence of support, then relationship, estranged relationship, role ambiguity we are saying, and change, ignorance of change. So, in that way we have changed the variable, and accordingly the data collected, these questions are also required to be changed. Suppose those questions which are positive in nature, for example, control strongly agree, that means 5, it will be reducing the job stress. So, we have reversed the questions also, correct. So, reversal is required for the negative questions in the sense we are developing, and accordingly what happened, we have gathered the information. Now, this is the status from box plot point of view. For there are 7 response variables. Variable 1 is lack of, that is it is L demand, means it is excess demand, then lack of control, then lack of management support, lack of peer support, then estranged relationship, role ambiguity, ignorance of change. We are seeing that the first one is officers box plot, second one is maintenance worker box plot, third one is your operations worker box plot. You see the mean value everywhere, there are certain what I can say outliers values are there. It is always better you first remove the outlier and then. Now, question is there is differences, it is almost visible that there are some differences probably, but we are not able to explore this how much differences is there. And in addition, job stress is such a issue which is individual oriented, means although there are 10 factors, all are affecting you, getting me. Then what? That means one factor at a time if we see, we may not get the clear picture. We have to see all the factors simultaneously. If you take one factor at a time, then it will be ANOVA. So, we are taking all factors at a time. Why? Because all factors are simultaneously occurring on the employees. One ANOVA, what will happen? The ANOVA will give individual factor differences, but it may so happen that the covariance structure of all the response variable are governing what is the stress level imposed on or exposed to the different employees, getting me. So, what is required then? It is required that we must collectively assess. Why MANOVA? That is why. This is because we will go for MANOVA, because to know the collective effects. So, this is what is our first level of information, and individual box plot says there is differences, but we are not sure enough that how much differences is there or whether really there is difference or not, and if there is differences, which of the variables are making these differences. You see now the data vectors. What you require? First you have developed questions, you have taken the responses, then you are creating the variable values. How do you create values? How many variables are there? 7 variables are there. How many questions are there against each variable? There are 8 questions again different, all those things. Oh, what will be the demand value? So, demand value will be sum of all 8 questions values or mean of these 8 questions values. So, we are considering that as 8 questions are asked against demand, we are expecting that these 8 questions are required from the content validity point of view. So, we are not going for mean responses, we are going for summated responses. So, that we have done, and accordingly the result, the data whatever we got, that is like this. So, x1 bar means that is basically for officer, that this is for demand mean, then control, management support, PR support, your relationship, role and change. So, in the same manner officer, maintenance worker, operations workers mean vector you have to compute. Understood? Tanmay? This is you have to do, because you have collected data, all those things. Now, for MANOVA you require the means. Here means are all mean vectors, because we have more than one variable. Once what more you want? You want the covariance matrices. So, you require to use software or Excel, MATLAB, wherever you are compatible. So, first second your work is for data point of view, you find out covariance matrices. You see that S1 covariance matrix is like this, here 54 officers observations were there, then S2 is the maintenance worker, 96 workers were there, and S3 is the operation worker, again 149 observations we have collected. So, your inputs to MANOVA x bar means x bar in the sense x1 bar, x2 bar, x3 bar and S1, S2, S3, that mean vectors and covariance matrices. Then your hypothesis, we are saying that all the groups are equal in experiencing the job stress. There are 7 risk factors. So, 7 mean values will be there. Each of the mean values across the 3 groups, that is equal, and that is why you see what we are writing here, that first one demand, 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 control, 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 like this. So, every values are equal to the corresponding values in the vectors. What is your alternative hypothesis? We are saying no, at least one pair, maybe mu 1 1 mu 1 2, they are not equal, or maybe mu 7 1 and mu 7 2, or mu 7 2 mu 7 3, they are not equal. That is your hypothesis. What you require to do? If you want to use MANOVA, you have certain assumptions. Those assumptions must be tested. What are those assumptions? Population covariances are equal, independent sample, errors are normally distributed, errors are IID. Now, independent sample mean we are saying that officer and workers, or officer, maintenance workers and your operations workers, they are independent. When you are capturing data from officers group, this is not influenced by the operations workers responses, they are totally independent. That is the first one. That is say, now population covariance is equal, what statistics you will use for MANOVA? In MANOVA, box M, we will use box M test. So, let us see what is this box M test. So, box M test, as we have discussed earlier, that it says that there is no differences in the covariance structure across the different populations, or other way if we consider it is a factor across the different levels of the factors, where it is factor is the designation group, officer, operations worker and maintenance workers. And our alternate hypothesis is yes, there is difference in at least one of the pairs. Okay. Then we have used D equal to 1 minus u m, and m is this S pooled SL, this one. Can you remember this one? You have seen this earlier, and this one when you have taken this one, when we have taken log, this is the formulation. So, that means what you require to do? You require to calculate the determinant of each of the sample covariances. You also require to compute S pooled and take the that determinant of that S pool, and there is one quantity u which is given by this measure, and you have to test what is S pooled. S pooled will be, suppose n 1 minus 1 S 1 plus n 2 minus 1 S 2 plus n 3 minus 1 S 3 by n 1 plus n 2 plus n 3 minus 3. So, that also you have to calculate, and now see then using this D statistics, and this D statistics will follow chi-square distribution with new degrees of freedom, where nu is 1 by 2 p into p plus 1 into L minus 1, p is the number of variables and L is the number of groups or number of levels or populations. Now, see we will show you the box test here. So, as the data is exhaustive, large amount of data, and we cannot manually calculate, what I have done, I have used Excel. In Excel you can very well calculate all those things. So, first we have calculated SP using this formula. Using this formula we have calculated SP. Okay. And you know S1, S2 and S3 is also computed. So, what will be the S calculation? 1 by n minus 1, then x minus, what is this? S will be p cross p, x is n cross p. So, it should be subtracted by mean. Mean is what? Mean is p cross 1. So, you want n cross. So, here 1 mean transpose, this 1 is n cross 1, this one into x minus 1 x bar transpose, and here this will be transpose. Okay. So, I am writing again, for everywhere when you calculate S, suppose you are calculating S1, then you are writing like this, N1 minus 1 x1 minus 1 x1 transpose x1 minus 1 x1 transpose. This is the case. So, using this you will be getting S1, you will be getting S2, you will be getting S3, and once you know S1, S2, S3, you will be getting S pooled, and this S pooled value is given here. So, it is 7 cross 7 matrix. Now, then you find out log determinant of S1, what is already there, S1 is there. So, in this case this is 10.96, log determinant of S2 is 12.17, log determinant of S3 is 13.56, log determinant SP is 13.12, and then we calculated M. How we have calculated M? We first calculated this, that L equal to summation L equal to 1 to capital L N L minus L, this one, this quantity first computed, followed by this quantity, then we have subtracted this value, and this M value is coming here 139.89. Similarly, we have computed the U value, this minus this and this also come to the value like this 0.027, and D equal to 1 minus U into M, that is 136.16. Now, what will be its degrees of freedom? Degrees of freedom is half P into P plus 1 into L minus 1. So, degrees of freedom is half P means 7 into 7 plus 1 into L minus 1, that is 3 minus 1. So, 7 into 8, that means 56. So, our case is chi square 56. Now, what will be your alpha value? You choose. If you choose alpha value equal to 0.05, then chi square 6 0.56 0.05 is 78.40, you will get from table. Now, this 78.40 and your computed statistics D is 136.18, which is greater than tabulated one 40, that means null hypothesis is rejected. So, H0 is rejected. What does it mean? It means covariances are not equal. So, what should we do? One of the assumption is covariances must be equal, but we are unhappy because covariance matrices are not equal, and we are not able to go for MANOVA traditionally. But what we have searched, I have searched the literature, I found out that still MANOVA can be done, but for the state statistics of MANOVA you have to rely on not only the Wilks lambda, you have to go for some other statistics, and you compare 4-5 statistics are available. If all the statistics or majority of the statistics says that okay, there is difference in the mean vectors, you can consider the result. Getting me? Also, the suggestion given that it is better always go for equal sample size. How do you go for equal sample size? Here I have 54 observation from officers, 96 from maintenance workers, and 149 from this. What I mean to say that as we found out this is the case, so the next step should be, why can't we go for bootstrapping? This is a beautiful concept, all of you, because you all will be using data, you are collecting from different sources, and you will be facing the problem of unequal sample size also. So, what I mean to say, can you not go for bootstrapping? Bootstrapping, what will happen? You will sample from this 54 with an assumption that the 54 is representative of the total population, and in that case here you do oversampling and here you do undersampling. Then what will you fix to maybe such let 100 data points. By doing oversampling, make it 100, by doing undersampling make 800, or if you want to say no, I want to make everything 500, that also possible. Then in every case you might go for oversampling and make it 500. So, once equal data points are available, then it is suggested in literature that even though covariance structure is not equal, you can still go for MANOVA. And then what if covariance structure is not equal, also mean values are not equal. So, mu and covariance structure are not equal, it also give us one advantage. What is the advantage? We may not go for a MANOVA, but what will happen because of this, we can say that these populations are distinctly different. So, separate model for each of the population we can do, some other model, not MANOVA model. Suppose I want to do regression. Now, this box M test shows that covariance structure is different, and mean values also we are that from the box plot, individual box plot, we found the mean values are also different. We have not tested collectively. Now, then I can go for, suppose I want to see that how the demographic and workplace variables are affecting job stress, then I will develop different model for the different groups. So, that is another advantage you will get if this will come. Anyhow, but what I have written here, we may proceed with an MANOVA as our sample size is large and MANOVA statistics are robust. Now, see that what happened, we have done MANOVA. You have a look on the slide and you see that box M test it is basically very significant, that 0 values, it says that null hypothesis is rejected. Now, we have also done the Bartlett's test of ferocity, that means what we are trying to say whether the 7 factors are independent or not, but what we have found out that significant value 0 this, that means they are correlated. See how the issues are coming here. So, as they are correlated, their covariance structure is different. So, if correlation is there, can we not go for some other model? Can we not do principal component analysis and extract maybe lower number of dimensions, and then we will go for MANOVA? Getting me? In principal component analysis, I will show you this one. I think you please remind me, many a time I forget. Suppose we will go first do principal component, all the 7, then we will see that what will happen ultimately, whether the again the box box M test will give us what type of thing. I think we have to check, because from the application point of view we are considering all the things. Okay. Then what is that, using this MANOVA, how I got these values, these I have used SPSS. You can use SPSS, you can use SAS, you can use Minitab, you can use Statistical. So, there are many softwares, or you can simply use your MATLAB, just develop program. Then here the Pillai stress, Wilks lambda, Hotelling stress, Roy's largest root. So, 4 statistics we have considered, and if you see the significant level, everything will almost 0, equal to 0, almost 0. What does it signify? It signifies that there are mean differences across the 3 groups. Although I said that box M statistics says that there is a violation, but if I consider, okay, let us go for MANOVA and do this, then all the tests are showing that there is differences. Whether you will accept it or reject it all depends on your requirement, but when there is violation in the assumptions violation is there, if you think that the results of MANOVA are still useful, use with caution. That means you must be conservative in making bold decisions. Okay. Otherwise, what is required, you go for some other data collection and some other test. Another issue, then as that is a heterogeneous case now. So, you all know that how that heterogeneous case, how we will make it to homogeneous one. So, there are transformations. So, before doing a MANOVA, you can go for transformation, power transformation you do, and I am sure I have not tested the multivariate normality here, but as it is heterogeneous one, the multivariate normality collectively if I see that, I think it will not be a multivariate normal case, it is likely. So, we have to remove outliers, we have already seen there are some outliers. Okay. So, coming back to MANOVA, what I can say that yes, there are differences. If there are differences, then you go for, I think this is the you go for finding out where is the difference. Okay. So, these are basically what I am showing that earlier, the computation part, and you all know how to compute, although I have shown you the result that all multivariate test, this hoteling you are not hoteling, that Wilks lambda, will be SSCPE determinant by some that SSCP T determinant. So, those things, but these are the computational formulas you will be using, and these are the data decomposition, that means this is SSCP B, that is the between the group population, then this is the error covariance matrix, then those two will be combined to this one. Now, interestingly, when I go for marginal means plot for officers, maintenance worker and operations worker with respect to all the variables, their peculiar results are, we found out some results are interesting in the sense, one is officer, two is maintenance worker. When we talk about that demand part, it is seen that maintenance worker, they are saying their stress related to their job is less compared to officers, and operations worker demand is more. So, if you go for now for the difference, that which one is different, whether 1 versus 2, 1 versus 3 and 2 versus 3, I have shown you already that Bonferroni intervals you can find out. Okay. For each of the difference you can find out the confidence region, and then from confidence region to simultaneous confidence intervals you can use Bonferroni approach. Okay. The marginal plot is showing like this, but when we are talking about case study, that means there all those things will be at the back end, basically the Bonferroni and all those things. Your answer, your interpretation of this is required for the interventions. What is intervention here? That job stress intervention. How better can you design the job so that the job stress will be reduced. Here from demand point of view, officers are having the highest level of job stress. In this case, from control point of view, operations workers are having the maximum. Getting me? That how interesting this one. See, it is obvious that officers are always having better control because they are more empowered. The operations worker, they are doing day to day routine work, and most of the things are routine, already structured, SOP, standard operating procedure is known. So, there is highly any chance to have their discretionary power. So, control point of view, these operations groups, that is why they are saying the job stress is more. Then you go to the third one, again if you see that from the management support point of view, operation workers are saying they are better placed. That means they are, for this particular company, they are getting better support, but whereas maintenance worker and officers are still at the higher level compared to definitely operations worker. This higher level, it is not absolute higher level, it is a comparative higher level. So, similarly, if you go for that marginal means for peer support, in peer support point of view also officers are not happy, because the high intellectual people never united. There is always your conflict in the sense, but lower level for the survival they have to have that group business. So, peer support point of view, operations and maintenance workers at the same level. Then officers, maintenance, then you go by the relationships. From relationship point of view, maintenance workers are saying their relationship is little poor, and it is reason is there. Maintenance is an unstructured job. For example, suppose there is a machine which is under breakdown. So, that machine require electrical people, maybe mechanical people together. Now, see, the electrical people department is somewhere, maintenance mechanical department somewhere, and they are mixing when it is required. So, it is not that every day they are looking after their jobs simultaneously. So, it is quite obvious that their relationship has not built up to that level compared to your operations and officers. Operations are having low job stress with respect to relations, and this is basically all are matching. Although, see, box rim test does not satisfy that there is the equality of covariances, but still we have gone for MANOVA, but the results are interestingly giving us conceptually correct result, and which we can test through. We have to go to the field and we have to test with the talking to the people who are actually working there. Now, you see that role, if you see the role clarity point of view also, officers are saying that there is difficulty, but maintenance workers they are saying, no, we know what to do, and operations people are having little more, but that may not be statistically significant. Now, come to your change again, it is supporting the concept. See, as maintenance people will go somewhere to maintain, that is not their department. For example, in CET there is a maintenance problem, the people will come from maintenance group department of IIT Kharagpur, that is not their department. Okay. So, whatever changes are taking place here, it may not be noticed by the maintenance people there. So, ignorance of change is definitely more for maintenance workers, and interestingly our study is saying that. Now, if so many good points coming out of a study where even the this thing what I am saying that box test is not giving you this result required results, that is why what we will do, should we go for by this conceptually correct results, or we will go for one more study. Definitely, to be in the safer side, you repeat the study, or you increase the sample size using box plot, you remove the outliers. These are all things has to be done initially, and transform the variables. So many things you do, and then you see that all the assumptions are satisfied, but and if it is marginally not satisfied, no problem. Okay. So, I think you got a interesting study. I think this is interesting study, that is because it is showing it is basically confirming the concept, confirming the situation where the people are working. So, all statistics, most of the time statistics confirms what you know, you want to confirm through data, and that is what is happening. Now, here what we require that some other, because post hoc comparisons is required. What are those things? Basically, you want to test, okay, there is difference, but which group are different? Here wherever you are getting the star marks, these are different. So, that means from demand point of view, officer and maintenance there is difference, and maintenance workers and operations worker there is difference, but officers and operations worker that difference is not significant. So, similarly from control point of view, that officers and operations workers the difference is there. Management support and peer support point of view, although we found out that there is absolute some differences in values, but statistically none of them are significantly different from alpha, that 0.05 probability level of significance. Then relationship point of view, you see that the operations that maintenance workers and operations workers they are different, and role point of view that officers and maintenance worker difference is significant. Change point of view, maintenance workers and operations workers are different. What are those other values? These values, this value, this value, this value, all those values. This is what is basically the significance level. Okay. This is the standard deviation of the estimate. This is the mean value in the mean difference. This is the standard error. This is the significance level. This is the lower confidence range value and upper confidence value. And you see, wherever star is there, there is not 0 in between. 0.41, 3.9, no 0. Star is not there, -2 plus. Then star is not there, -2, -2 this. Getting me? So, then my conclusion is, employees differ in job stress both from mean and variability issues. Officers are not happy with demand, management support, peer support and role. Maintenance workers are concerned of management support, relation and change. See, there is job stress, absolutely it is there, and it is no study is required to know this, because it is seeing the face, it is also possible to understand people are under stress. But what this study is giving, that the job stress are because of many reasons, not that officers job stress vis-a-vis operations workers job stress are caused by the same causes. It is clear from this study that officers from demand, management support and peer support and role point of view there is problem, whereas maintenance worker case management support, relations and change, and operations are primarily stressed due to demand and control. Getting me? So, this is what is the beauty of our statistical modeling, and it is giving you clear cut answer that where you will stress. And even though our study there is little problem, but all the 4 statistics we have taken for what I can say that to check whether the differences are there or not, everyone support it, every statistic support it. Okay. So, with this I conclude that MANOVA is very useful, and this is only one way MANOVA we have seen. There will be 2 way, because here what we have taken only the designation part. You can take something else. For example, job stress is not the designation problem only. People are coming from with certain socio-economic status, family burden and other things. So, many other things are there, you can check. So, if you find out more variables, maybe your study will give you much better results. Okay. Thank you very much.